Hello everyone. This is the second problem of the assignment number 5. I'm going to explain you how to implement a queue using two stacks. There are two methods. First method is by making the NQ operation costly, and the second method is by making the DQ operation costly. This should be DQ, sorry, that, and this should be NQ. So when we are making NQ operation costly, that means we want to make sure whatever the first element entered in the stack is at the top of the stack, so that whenever we are removing the elements, the first element entered should be at the top, so that we can pop it out, and that will be our DQ operation, which is less costly. Now to NQ the to NQ means to add the elements to the stack, to the queue. First, if 5 is added, means we will check if this stack S2 is empty. If it is empty, then we will move all the elements from the stack S1 to this, and then we will add this new element here. And after that, we will start popping those out, and we will pop all elements, and we will NQ them from on this stack, so that this 4 will be next step. This 4 will be at the bottom and 5 will be at the top, because 4 will come out as last in first out for the stack, and 5 will be at the top. So whenever we are dequeuing, this 5 is the element which is entered first in the queue, so that operation is less costly. And again, suppose if we need to add 3, in that case we will start this stack will be empty. We'll check, then we will copy all these elements, or we will pop these elements and push these onto this stack, and then we will add the new element, which is 3 here, and then we will move all those elements in the last in first out manner, so that again 5 is at the top. Just like that, we can add elements. NQ operation, this operation takes order of n time complexity, and DQ will take just popping out the last element, which is the first element entered in the stack from S1, and that is order of 1 time complexity. And the second method here is making the DQ operation costly. That means whenever we are NQing, we'll just enter the elements in the stack like this, like 5, 4, 3, 2, 7. So there is no need to copy these to this stack elements, or make sure that the first element entered is at the top of this stack. So we will just keep adding the new elements on top of the stack top elements. And for dequeuing, we need to return, whenever we want to dequeue from the queue, we want to return the element which is entered first in the queue. So we will first what we will do is we will pop this stack, and we will push all the elements on this stack S2 till we reach the first element in or last element in the stack. So that will be like, so there is suppose 7, 2, 3, 4 and 5. Then all the elements 7, 2, 3, 4 are popped from this stack and pushed to this stack, and this 5 is returned, which is the first element entered in the stack, and that is your DQ operation. For this, time complexity is order of n. Suppose again if I need to NQ one more element, so and after that we will push those elements, and in this case these are, so this is 7, 2, 3 and 4. And then we will copy those elements, pop those elements and push them onto the stack. And here the NQ operation is less costly, where we are just adding the new elements to the stack. Now we'll look at the implementation part of this. So first implementation is by making the NQ operation costly. Here the two queues are two stacks given are S1 and S2. This is the NQ operation, where we want to add the new element to the queue. where we will pop all the elements till this count is 0, means till the first stack is empty. We will pop all the elements from the first stack and push them to the S2 stack S2, and then we will push the X to S1, means like we will move the X to S1, and then we will again we will push everything back to the S1, that is S1 S2 dot pop means we will take out the elements from the second stack and push them onto this first stack. Now this operation has the order of n complexity, and the second operation on the queue is, which we are implementing, is dq, where we are just when the top of this count or number of elements in the stack is equal to 0, then the queue is empty. Stack S1 is 0, then the queue is empty, or else we will just remove the first element or we will peek the stack S1, and that element is the element which needs to be popped out or dequeued, or the first element which is entered in the queue. Now the second method here is by making the dequeue costly, where first we will put, for enqueuing we'll just push the X to the stack 1, and this time complexity will be order of 1. For dequeuing, if both stacks are empty, then there will be an error, that will be the edge case, that there is no queue or there are no elements. If the stack 2 is empty while stack 1 is not empty, push everything from S1 to S2. Now pop the element from the stack 2 and return it, which is on top of that stack, and that will be the first element of the queue which is entered in the queue. So the time complexity will be order of n, and the implementation looks like this. These are the two stacks, and then enqueue is just pushing the element onto the stack, so it's order of 1 operation, and dequeue is like little complicated, so the complexity is order of n. First, the element which needs to be dequeued, we will declare a variable x. So if both the stacks are empty, then we'll throw an error, or the queue has no elements, and that is queue is empty. Now we will move the elements from S1 to S2 only if S2 is empty. If S2 is empty, then we will move all the elements till it is not equal to 0, and then we will pop the last element in the S2, which is the top element, or which is the first element entered in the stack S1, and that is our dequeue operation for the queue, and the time complexity for dequeue is order of n. Thank you for watching.